Hello everybody, Root Beer here, and we're looking at question number 2 on the 2007 Grade 12 Euclid Math Contest. So, if you'd like a copy of this contest, and I do always encourage you guys to get a copy to practice, you can click the very first link in the description down below and get a copy for yourself. And if you want to try this question or any of the other questions out before I get to them, feel free to have a go at that, and that way you can tell was I able to get this question, or did I need that crucial hint or that crucial piece of information? And if you want to try question 2 before me, feel free to pause the video. But I'm not waiting, I'm getting into it. Question 2, broken down into 3 parts here. We've got 2 of the light bulb questions that just require a final answer. They're short answer questions. And then we have the long form, write down everything, justify everything style questions. Okay? So 2A. In the diagram, triangle ABC is right-angled at B, and AB is 10. If cosine of BAC, this angle right here, is 5 over 13, what is the value of tan ACB? Okay, so that's this one up here. Alright, well, they've given me cosine as a fraction, as a ratio. And so I remember things like TOA. And that has to do with a triangle. And if I'm talking about one angle here, theta, I have the hypotenuse, I have the side opposite my angle and the side adjacent to my angle. Something like the ka here means cosine, for C, of theta is A over H. Okay? So they've given us that sort of information. Now we can take that and go to our notepad and work that out. So I'm going to call this one theta, and we'll call this one, I don't know, phi. Okay, so we're told cos theta is 5 over 13. And we want to find tan of phi. Okay, so with SOHCAHTOA, cosine tells us that, so there's our B, there's our A, there's our C. So cosine tells us that opposite of the angle, CB, or sorry, not opposite, adjacent. What am I doing? Adjacent to the angle. So AB, which we know is 10, over the hypotenuse AC is the same as 5/13. Now tan of phi is, so we do so sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and TOA, tangent, is opposite over adjacent. But because we're talking about this angle up here, the opposite side is AB, and the adjacent side is BC. Okay. But now that we know that we've got this 10 down here, they told us this 10, we can use our first ratio to figure out AC, and then use the Pythagorean, so it'll get us up here, and then we can use the Pythagorean theorem to get BC, and then we'll have our final ratio. So 5 over 13 is the same as 10 over AC. Well, you can cross multiply, do whatever you want, but you're going to see that AC is 26. I just multiplied, how do I get from 5 to 10? I multiply the top by 2, so I multiply the bottom by 2. 13 times 2 is 26. Okay, so we've got 26 for AC. Well, AC squared is equal to AB squared plus BC squared. Okay, if you want to, make a little note that you're using the Pythagorean theorem. We have 26 squared is 10 squared plus BC squared. So 26 squared is 676 minus 100, which is 10 squared. You're going to get 576. And you're going to get that BC is 24. Okay, so the tangent that we want, tan of BCA, tan of phi here, is AB over BC, which is 10 over 24. Divide 2 on top and bottom, we get 5 over 12. Okay, so that's our final answer. That's all we needed to get, 5 over 12. Okay, just double check, we did want A, C, B. Yep. All right, so that's A part. How about B part? Suppose that x is an angle between 0 and 90, so it's a strictly acute angle. And we know that 2 sine squared x plus cos squared x is 25 over 16. What is the value of sine x? Ooh, okay. So, what can we do here? So, 2 sine squared x plus cos squared x is 25 over 16. All right. Well, sine squared plus cos squared, that's something that we should know from trigonometry. Now, we don't just have sine, we got 2 sines. But let's break this into sine squared x plus sine squared x plus cos squared x is 25 over 16. And now, these two together, no matter what x is, sine squared plus cos squared is always 1. So what have we got? Sine squared x plus 1 is 25 over 16. Well, let's subtract 1 from both sides. And we're going to get 9 over 16 when all is said and done. Hey, I can square root this. Sine x is either going to be 3 over 4 or negative 3 over 4. And we have to decide which one it is, because they want us to tell them what sine x is. Okay? And that's where the information that x is between 0 and 90 degrees comes into play. Sine in this range is always positive. Now, there's lots of ways we could try and remember that from trigonometry. Okay? There's lots of ways. Some people just memorize the circle definitions, which when you put that, when you sort of have that understood, you know exactly where sine's going to be positive, where it's going to be negative, where cosine's positive, cosine's negative. And that's useful. Some people, instead, just memorize this, the ASTC. You start in the first quadrant, then go to the second, then the third, and finally the fourth quadrant. And the way you can remember this, like all students take calculus. All students take calculus. I'm a big fan of all soup turns cold, because that's true, because you can't expect perpetual thermal generation. But basically, what does this mean? So S, C, and T are our sine, cos, and tangent. This just tells us what quadrant our angle has to be in for these things to be positive. Okay? So, and the A stands for all 3 of them. So all 3 of sine, cos, and tangent will be positive if our angle is in the first quadrant. Only sine is going to be positive if we're in the second quadrant. Only tan will be positive if we're in the third quadrant. And only cosine will be positive if our angle takes us to the fourth quadrant. But 0 to 90, that's definitely here, so sine has to be positive. So sine x, it's not going to be negative 3/4, it's just going to be 3/4. And that's all we needed. We don't need to explain are all soup turns cold or anything like that. They just are looking for the final answer. It's a light bulb. So this question boiled down to, do you remember sine squared plus cos squared is 1? And do you know that the negative version of sine is going to be rejected? So that was probably 2 marks, maybe 3. Okay. So what do we got left? We've got C part. In the diagram, BC is equal to, AB is equal to BC, which they have labeled for us quite nicely, and it's 2 root 2. Okay. CD is equal to DE. All right. And CDE is 60 degrees. But hey, this is isosceles, so these guys are going to be the same angle as well, and they're going to have to be 60 as well. We'll write that up because this is a written question, but we know those angles now. And EAB is 75 degrees. Also, because we got this 90 down here, we can tell that each of these is 45. Again, by isosceles triangle stuff. And if that's 75, that'll be 30. And then with this 90 here, we'll have 60 here. And we'll have all the angles. But what are we asked for? Determine the perimeter of ABCDE. And of course, explain how you got your answer, because it's a written question. Alright, so we need perimeter, so we need to start figuring out lengths. I've figured out all the angles. I'm going to have to write up a little bit about that, but I've got all the angles. I guess from these lengths here, we can get this hypotenuse here, and then this length, and these other lengths. Yeah, this should be doable. Well, of course it should be doable. It's question 2C. But let's draw our picture. So we have A, B, C, right angle there, right angle. Oh wait, no, this is E, wasn't it? No wait, E was over here. Yeah, E, D, A, B. Let's just double check. Yep. All right, so we know these two are the same. So I might say something like ABC is isosceles. So angle ABC is equal to angle, or sorry, not ABC, BAC. BAC is equal to BCA. And I might say something like, since angle ABC is 90, therefore both of these guys. You could turn it into an algebra thing, but you got bigger fish to fry in this question. So we're just going to say, yep, we know these angles. These ones are 45. And we still have our 2 root 2 here. Okay, so should we lay it out? I think we'll lay out all our angles first. And go from there. Okay. So, what else can we see? So, angle EAC is equal to angle EAB minus angle CAB, which is 7. Make sure that looks like a B, which is 75 minus 45, which is 30. Therefore, angle ACE is 180 minus 90 minus 30. We have 60 degrees down here. Okay, finally, CDE is also isosceles. So angle DCE is equal to DEC, and these guys are also 60 degrees. So we might say, since CDE is 60 degrees, therefore, and again, if you want to explain this, go ahead, but I think it's just enough to state all these angles. And as a consequence, CDE is equilateral, and therefore CD is equal to DE is equal to EC. Alright, that's going to be useful, because here's our plan of attack. We are going to get this hypotenuse, which actually doesn't help us with the, well, it doesn't give us any part of the perimeter, but it does help us. From there, as a hypotenuse for a 30, 60, 90 triangle, we are going to get both of these fairly quickly. And then from there, we are going to get CD and DE, and then we will have AB, BC, CD, and DE, and EA. Okay, so that's our plan of attack. So, and you could even label the diagram that way. So 1, AC squared is AB squared plus BC squared, which is 2 root 2 squared plus 2 root 2 squared, 16. Therefore, AC is 4. All right. Part 2. All 30, 60, 90 triangles have the same ratios. You can use trigonometry if you want to get them. Or you can remember that all of them are in the same ratio. Opposite the 30 degrees, we'll call that 1. Then opposite the 60 degrees will be root 3 times that. And the hypotenuse will be twice the side opposite the 30 degrees. So you could say that, you could do some sine and cosines, whatever you want, but I'm going to say, since A CE is a 30, 60, 90 triangle, and they'll know what you're talking about. These people love 30, 60, 90 triangles. They pop up just about every other Euclid, I would say. We see which one's opposite the 30. CE is AC over 2, and AE is root 3 times CE. So CE is 4 over 2, which is 2. AE is root 3 times 2, which I choose to write as 2 root 3 so I don't get confused when I'm in a rush. All right, and finally, we've got step 3 here. CD is equal to DE is equal to CE, which is 2. So what do we got? Perimeter is AB plus BC plus CD plus DE plus EA, which is 2 root 2 plus 2 root 2 plus 2 plus 2 plus 2 root 3. There's not really a simple way to write that. I'm just going to say 4 plus 4 root 2 plus 2 root 3, and that's really the best way to write it. Okay. And that's all they were asking for, right? Yep. Determine the perimeter of the figure. There we go. We explained it. We talked about the angles first. I think it's very good that we sort of have a plan of attack. We didn't just figure out things as we went. We did angles, and then we got our lengths in order, and then we just added them all up. So there we go. That's question number 2, all done on the 2007 Euclid. Up next will be question number 3. So as I said at the start of the video, feel free to try question 3 before I get to it. Remember, practice makes perfect. And, maybe you don't care about the 2007 paper, but it's great practice for whatever paper's coming up, whatever, year paper you're watching this for. Okay? So I will see you for question 3 next time. Until then, take care and have a wonderful day.